So in this session, we are going to understand what is meant by insertion sort. We have seen two kinds of sorting techniques, that is bubble sort, and second one is the selection sort. Now in this session, we are going to understand the insertion sort. So insertion sort is nothing but whenever you play cards, normal cards, that 52 deck of cards, that when you play, how you will play that. So whatever the correct card that you will take and you will place in the correct position. So that is the simple way of saying you what is meant by insertion sort. So if you read the sentence that is present over here, it is saying taking element from the unsorted section, place in the sorted section. So that is the meant by a simple definition of the insertion sort. So let's say assume you have an array called nums. So 0 index base, so you have 5 elements, okay. So now as you are taking, as this is also order of n square, because you are going to have nested loop. So with the first loop as I, the outer loop, and the inner loop as j. But here you need to understand that j is the before of I. Means if I is the first index and j is 0 index, so that means j is equal to I minus 1. That's the simple thing that you have understood. You can also see the same stuff here also. So basically you have the array, you have the I is equal to, suppose I is equal to 1 and the j is equal to I minus 1, which is 0 in this case. You can see clearly over here. And we are going to have another variable called key, which is indexed with nums of I, which is in this case as the 6 value, okay. You can also see that nums of I, or we can also call it as key. We are assigning this key value to the 6. So why we are assigning key? So I will explain to you in a moment. So these are from the if you see, this is the small this is for outer loop, outer first loop. So we are initializing I with 1, you can see over here, and I less than n, I plus plus. So we are taking a variable key which is for the nums of I and integer j which is I minus 1, means j is pointing here. So after that the nested loop, the inner loop, that we are taking nums of I, so nums of j which is greater than key. Now what we are going to compare is, we are going to compare j and key. So you will understand that what we are going to comparing. So first of all, we are going to compare the j and this. Now here what I did is, basically if you see clearly over here, I am comparing 3 and 6. So there is no issue, I got forwarded. If you see clearly here, I am comparing 6 and 2. So if you compare 6 and 2, which is bigger? Of course 6 is bigger. So take the 6 to here, a simple problem. But don't keep these two directly over here. That if you do that, then the bubble sort will come here. So don't do, instead of that, take these two out and keep in this key. So as you can see, now why I am keeping key as 2, because the key is now nums of I. After that, move the nums of I here, as the nums of I is this one. So that now k becomes 2 because you take out that key. So now compare this key and this j. So move this j here also, okay. Now j is here and place this key here, okay. So you have placed j key here and you have placed that 3 here. Now you can compare. After that you are mentioning the j minus minus. So after that, j minus minus means there is no space, it is going to minus 1. So that is not possible. So if you observe, what I am saying is, so nums of j plus 1 is equal to nums of j. So what is meant by this statement? So as in the before here only, you can see nums of j plus 1 is equal to nums of j. So so whenever j is j is not here, you can put j here. So nums of j here means nums of j plus 1 means here. You are assigning the value of nums of j. So what is the nums of j? Nums of j is 3. So basically this 3 will come here and nums of j will be here. Nums of j, okay. Now what is meant by this code? After that you are going to do j minus minus. So j minus 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 is nothing here. So now here comes is j into j is equals to I minus 1. So if whenever you see this statement, so in this while only you have to mention another condition. The condition is, whenever you that condition works, the while loop works only when this j greater than equal to 0, okay. So j will be not going here, then you can simply assign this keyword. So nums of j plus 1 is equals to k. So you, as you are storing this key here, so as you are storing key here, so simply place this key inside this j plus 1, okay. As you are moving j here, so place simply j here. So after that, what you can do, so as the I is as I is what? I is 3, you again moved I here. So as I becomes 3 here in this outer loop, I am saying I moves here, then j also move to I minus 1, which is the second position. So with the help of this loop, again you can check whether the nums of I here, the nums of this condition, whether the nums of j is greater than key. What is the nums of j now? 6. Whether this 6 is greater than key, key is 1 here. So you can see that that is not correct. So you are going to swap. Swap means place this 6 here, take this one out, keep in the key, okay. So after keeping the key inside this one, again you are going to move this j value here. So after moving j value here, you are going to assigning this with the help of like this here. So I hope you can relate this code with this diagram as well. Okay, so after that what you are going to do, again you are going to place whatever the condition 3 here, you can move here with the help of this line, and you can move the j backward like here, and the key is again the still 1. Okay, so finally you are going to place the key value here, and you are going to move the I value to 4 and j value to I minus 1, which is 3 in this case. So you are going to finally take out this key here and keep in the key value, and swap this key which is j value, which is 6 here, which I have done here. So because with the help of, like, if this condition satisfies these two conditions, with the help of this statement I swapped. Okay, and I moved j backward with this statement. Okay, now what I am doing is key value, you have to compare this key 5 with this j value. Why? Because here I am comparing array of j with the key, and I am placing that value here. So these conditions has been true, so I am coming inside here. So you can see the array of j, this condition false. So this condition has been false. So this condition is true, but this condition has been false because key value is what here? Key value is 5, and array of j value is what? Array of j value is 3. As array of j value is greater than this one, you are going to simply place nums of j plus 1 here. So you are going to place 5 value here. That's it. That is the condition, and you are going to finally place this nums of j plus 1, which is this here. That's it. So in the previous session we have seen up to here. Now I am going to change it to the insertion sort. So this will be insertion sort. Okay, in the insertion sort we have understood in the theoretical way. Now we are going to see practical way. So now I don't require this minimum index because we are not dealing with anything in the minimum index. So I will be going to remove this minimum index. So I will be completely removing of this inner loop as well. Okay, this is a simple outer loop. Okay, there is nothing complex here. Now what I will be going to say is, I will be not going to place rather 0 here. I am going to start the outer loop with the 1. Now I will be coming here inside that I will be going to make the inner loop, which I will say array of what? I will be going to compare with array of j, and here I will compare with key. So I will make the key as well, and I will be going to place AND operator here, and I will also make sure that j is greater than equal to 0. So there is no issue, but before this, while only you need to make a the variable called key, which will be initialized with this the nums of I. So there is no issue in this, and you also need to initialize the variable j. So I will say int j is equals to I minus 1. So generally the basic stuff that we have seen in the slides only. So I will clear this terminal first for you. Okay, so initialized the not array here, we are doing with nums. Okay, the array name is nums. You can see clearly over here the array name is nums, and you also initialize the size. Basically you are using the same size here also. Now inside this basically inside this while loop, what I am going to do is I am going to do 2 steps. So as you see in the slides as well, so I am going to have the array of j plus 1 that will be replaced with array of j. Okay, that's a simple step, and I will also going to perform j minus minus. So this is the simple not the array, that's num. Sorry for my confusion, this is not array. We have the array called nums, not air. Okay, not air. So you have made array of j plus nums of j plus 1, which is replaced by nums of j. So after that you are subtracting that see in the slides, this one nums of j minus minus. Okay, as this is moving back. So with that this condition, it will be going to C front only. So basically what is meant by that is you are seeing, make sure that this j, this not only you just swapped, means what is the problem? That becomes bubble sort, right? So you don't want that. So this key value should be compared with all these values and placed at the right position. So that is known as insertion sort. Insertion sort means you are taking the key value and placing wherever it fits. That is the as you place in the actual deck of cards when you are playing, how you will from all unsorted arrays, unsorted cards, you are placing in the sorted position. So similarly you are taking this unsorted key value and placing exactly where the value suits. So again, if you come to the code part, so after this while loop, what you are going to say is again the final thing, that is in this nums array of the nums plus 1, you are going to store the key value. So like this you are going to end all this stuff, and if you, so before that I am simply printing the stuff in this nums. Okay, after that after the sorting also I am printing the stuff. So if basically if you compile and run, so you can see, so if you compile and run, basically it is showing before sorting the nums, it is showing this one, and after sorting the array it is showing like this. So this is known as insertion sort. So basically in the insertion sort you are also going to have 2 loops. If you are using 2 loops, definitely mark by word, that is order of n square. If you are using one loop, that is order of n. As you are using for loop, inside that you are using again while loop, that is order of n square. So all the three, the bubble sort, the insertion sort, the selection sort, all of these three are the order of n square, because you are using two loops here. So in the upcoming sessions also, we are going to explore more sorting techniques. In that is more sort and all things we are going to have in the order of n log n also. So that makes our that is very faster as compared to this insertion sort. So in the outer loop, you are having a key value and the j value which is less than I, mind that. And in the while loop, you are just replacing the values or swapping the values. Now outer loop, you are keeping the actual value in the actual position. Here you are printing, here also you are printing after the sorting. So actually the last thing that here is we have left is the time complexity and space complexity of this insertion sort. So you need to consider only the worst case scenarios. The worst case scenario of this insertion sort, the time complexity is order of n square, as you are using two loops. So in the space complexity is order of 1, because we are not using extra space for the arrays. In the same array we are doing all the stuff.